that helps you run AI anywhere. And we're hearing this from all of our enterprise customers. They're putting a lot of investments into AI infrastructure, usually more than half their budget. But the problem is, if it's not going utilized, they're really throwing away almost half their budget, about 48% overall, when we're hearing stats like 80% underutilization. So compute is still a big problem. People are purchasing it, but you got to adopt it as well. We also hear about the security risks and the slowdown for AI teams by adopting many different tools to solve an AI initiative. We like to coin that the AI sprawl problem, where people are using upwards of 10 different tools in order to solve something. And for an IT team, that creates a huge security risk, because all these different tools, you're not really sure where they run, where your data lives at that point, and that's a big risk to your business. So we're hitting all three of these with the Clarifai platform. Today we're going to zone in on the compute orchestration, which is our latest offering that lets you run AI workloads anywhere. And we've partnered closely with Vultr to run it on their cloud, which is awesome. It brings NVIDIA GPUs, CPU nodes, and AMD GPUs all in one place. So Clarifai's compute orchestration is accelerator agnostic, so we can run across all those different types of hardware on each of our partners' clouds. And it's also model agnostic. We've wrapped some of the third-party models, so you can use your favorite, Gemini, OpenAI type of model. We upload the latest open source models, usually within hours of them being announced, so they can run on any of the compute you provision. And then, importantly, we can let you upload your own custom models, and we'll show you what that looks like today. So regardless of what type of model you want to use, it's available through our platform. And then when you're running the models that get orchestrated, we really drive down the cost, because we're doing things like fractioning GPUs, so you can run more than one model in the same card. We're also auto-scaling to and from zero, so when workloads are not in active use, they're costing you nothing. And we bring that with all the enterprise-grade governance and control features, audit logs, analytics, role-based access control, organizing into projects and teams. So you really have the full stack that accelerates you from prototype into production. Now, compute orchestration looks a little bit like this. We have a central control plane up there on the top. That's when you log in at clarifai.com, you're sitting in that control plane. And from there, you can provision compute in Clarifai's VPC across all the different clouds that we make available, including Vultr. And if you already have an account with Vultr and maybe a large enterprise commitment, you can also bring that into our platform and connect it from your VPC securely to our control plane. And then even if you have some machines running on-premise, you can connect those as well. Basically, the requirement is Kubernetes. Once you have that, we can run our stack and orchestrate AI workloads. And that helps you maybe start on-premise if you want to save the most, and then transition to Vultr to scale up automatically. And when we're talking about scale, we do it with high reliability and high throughput, and we'll show you in a little bit really low latency as well. We push the system past 1.6 million requests per second, far beyond what you would ever really need. And that secure connection is an important aspect. We're connecting in a way that you don't have to open up firewall ports or VPC peering, so your IT teams will really like it as well. And today here at Raise, we actually announced a new offering called Local Runners. So I talked about different cloud options, different VPC, on-premise Kubernetes clusters. Local Runners is the last step where you can actually run it on laptops. And so you can connect things like your local data source to an agent by talking over the MCP protocol, having a model running locally. You can run a large language model on your laptop, depending on how much memory you have. You can pick a small 1 billion parameter model, 3 billion, or I've been able to run DevStrel, which is about 24 billion on my laptop. And all of those tools or LLMs, they're available as a public API, just like a Kubernetes cluster is, or a VPC cloud account. So regardless of where it's running, it's a unified orchestration. And this helps open up a lot of onboarding for developers. They can start prototyping locally, and then changing one command, they can push it up to Vultr, let's say, and scale from there. So we make it really easy as an onboarding ramp. And it's compatible with all the favorite tools that you use. So agentic development toolkits, we speak the protocols of MCP, OpenAI, HTTP REST interface. So we're really excited about bringing that kind of compute and AI everywhere. Now, to implement a model or an MCP tool, this is the developer experience you get. Simply write a function. You could call it F, you could call it G, whatever you want. You can specify whatever arbitrary input and output arguments the function takes. And that might be a MCP tool, like a calculator, very simple to implement. Or it could be a complex thing, like wrapping VLLM to power a large language model on GPUs. So you can wrap anything with Python. And then on the right, you configure it. And you say, I want to run this on an NVIDIA A10G. I expect this model to use 18 gigs of GPU memory and 13 gigs on the CPU. And we take that information to help schedule it amongst other models and auto-scale things up and down. We also make it really convenient to pull checkpoints from Hugging Face, so you don't have to think about doing that separately. And then convenient from the command line. We have a one-line interface to do almost anything, like upload a model, run it locally, etc. So really built as a developer-first tool. And when you log in, it looks like this. So this is the control plane. You can see this local runners thing just started appearing today. And I can see some of my recent activity. And these are some of the trending models. So these are those open source models I mentioned that we upload. So they're ready to use. You don't have to worry about keeping up to date with state of the art. We take care of that for you. And you can test them out on your use case right in our playground. So I'll write something like that. And you can see it comes back really quickly, low time to first token, and all of our APIs are streaming, even bidirectionally. So you can do things like send in a prompt and it streams back tokens. That's one direction. Another is maybe video streaming, sending in frames of video as input and then streaming back predictions on that video in real time. So that gives you a way to test out which model may work for your use case. And then once you're ready to scale that, you're very likely going to want to provision compute. And that's where you can go to the Compute tab and create a cluster. And here we provide all the different options of partners we've connected. And so here you can pick any of your favorite instances on Vultr. Some of them have CPU only, some of them have different GPUs. We will be, actually AMD's already there, so here's the support for the AMD instances as well. And everything is priced per hour here, so you can dedicate a specific number of nodes to a cluster. And actually, you can configure that here. So maybe you have a sandbox, your internal team wants to start building, and you want that to be controlled, maybe 20 nodes so that they don't spend too much money. And 0 is actually an important number on the minimum because it means if there's no workloads, like your team goes to sleep, it'll actually collapse all the nodes to 0, costing you nothing overnight. And you don't have to think about remembering to do that. If you want to have dedicated uptime, you may want to hard code like 5 nodes up in production at all times, and then a much higher max. And you can give it, a name, all that kind of stuff, and that's it. So you provision compute to on where do you want to run your model, and then I've already uploaded a model. Let me just switch to an organization. So we support, grouping projects, which are your data, your models together, and you can manage projects as an individual or as an organization. So I'm in a demo account. And this model I've uploaded, it just basically prints out some information about where the model was processed. And I can type in anything and run it. So that just ran on a Vultr deployment. So this hit a machine in, I think, Chicago or New York. I can't remember which one. And it tells you what node pool it just ran on. I could run the same thing on a different cloud like that. I could run, on-premise in Kubernetes. And then, go back to Vultr and do another request. So on a request by request basis, you can actually dynamically route across clouds and on-premise the same way. I don't have a demo of the local runners, but it would show up here just like a Kubernetes cluster as well. So you'd be able to route even to this laptop calling our public API. So anywhere your compute needs are, you can run with Clarifai. So I covered some of this stuff in the live demo, and the fractioning, so now that you have a model up, you said I wanted 18 gigs of memory. What that looks like if you don't have fractioning is on the top right. Your GPU might have 48 gigs, it might have 80 gigs like an H100. And if your machine has multiple GPUs, your models are going to sit like that. They're going to take up some fraction, and then a bunch is not going to be utilized. And usually GPU memory is a big bottleneck, especially with these large language models loading to and from the memory. And so with a lot of that memory not utilized, you're not using the capacity of the machine. Whereas with GPU fractioning, it becomes a scenario on the bottom right. That model in yellow can sit next to the model in blue on the same GPU, and now you have two free GPUs. You can fit in an 80 gig model next to these ones, and you're driving up that utilization. So your cost investment in infrastructure is getting a higher total ROI. We also have a lot of tools around, I showed you only a glimpse of these, project management, team management. There's lots of analytics and more to come throughout the year on GPU utilization, latency metrics, all measured, broken down by cluster, by model, so you can really understand what is being utilized. And then you can actually provision things in a fine-grained permission control way. So you can actually turn on and off every single endpoint in our API and assign those permissions to an individual or a team. And then we have all the tools to help you create those AI workloads, like data labeling, where we automate the process using AI itself. We have things like similarity search on the bottom right, using a picture of a person's face, finding similar matches. We have one-click training, so you can train a large language model, fine-tuned on your data. You can train an image classifier, image detector, and then you can chain them together on the bottom left there using a visual workflow builder, so you can build agentic workflows all in one place. And it is fast. We really optimize this. We've been around since 2013 when I founded the company. We've been running inference since 2014. And it all started with image and video, which is heavier data than large language models. So when we benchmark on large language models, because of all the innovation that we've done for a decade on tuning inference performance, we come out on top compared to other great companies that talk about how fast they are. And that comes out in really low latency, time to first token, and higher throughput for the same model and the same cards. So we're really excited about this. And with all these cost savings, you're not only getting the fastest performance, you're getting the lowest cost when you start running things in production. And all these different features kind of compound with each other. Fractioning can be used independent of auto-scaling or spot instances for clouds that have it. You can batch multiple requests into one, so you're saving on round trip there. And that's kind of separate from, if you're reinventing the wheel, building your own inference stack, it's going to take a lot of your team's time. And AI, with all the news going on, AI talent is a race right now. So that you have better use of their time for other things. And so to get started with Clarifai, we are giving away a special promotion here in the Vultr booth to get 10,000 free credits to start using compute orchestration and driving utilization. We also help enterprises get started with AI sprints. This is a hands-on experience. We work with your team, bring in some of our AI experts, ideate on what is your biggest business problem, and then try and solve it in a matter of days with our platform. And then you can take that solution into production in a matter of days from there. So it's an on-ramp to solving your big business problems with AI. So thank you very much for joining us today here in the Vultr booth.